Hello, hello. This is Postgres FM. My name is Nik, Postgres AI, and as usual, with me, Michael, PG Mustard. Hi, Michael.
Hi, Nick.
And we have a very, very interesting guest today, Michael Mellis, who created pgrust, which has already, I think, 5,000 stars on GitHub and a lot of noise around, like a lot of buzz. Hi, Michael. Thank you for coming.
Yeah, of course. Thank you for having me.
So, of course, I think the first question should be how it all started. Why? Tell us the story, please.
Uh, So Jason and I were looking for projects to work on, and we wanted to do something that we knew super well. And initially, what we were focused on was reliability and how can we help people make their websites more reliable. And we were working with a bunch of people, and the common pattern that emerged was that a lot of the problems that cause reliability issues, a lot of them stemmed from their database and how they were using their database, whether it was like Postgres or Redis or some other system. And so we started looking at what are ways that we can solve this problem. And we were throwing around a couple things, and we ended up figuring out that AI is actually pretty good at rewriting software at this point. This is back in April. And so we're like, hey, why don't we actually try fixing these problems at the source and actually trying to modify Postgres and fix a lot of the things that cause people to have different reliability issues, whether it's connections or it's like certain queries just take a really long time, or like one long running query can take down your database, or vacuums, as we're all familiar with. And so the idea behind pgrust, the name's a bit misleading because it's not actually really about Rust. I think that's actually the least interesting part about it. It's actually more about how do we leverage AI to re-architect Postgres and just build a much better database.
Okay, and when you say better, what do you mean?
Yeah. So there's a combination of like different challenges that like I've just seen people repeatedly have with Postgres. And I actually wrote a blog post called it like the Four Horsemen about a lot of the challenges that people have. And some of the most common ones are like you misconfigure your connection limit and like all of a sudden like nothing can connect to your database. You have like JSON support. Like, tons and tons of people use JSON, but Postgres doesn't have statistics for how to actually query JSON. So when you try to do it, you're going to get really bad query plans and everything's just going to be really slow. There's like the wraparound vacuum, and you have more than several billion transactions, and like all of a sudden, if your vacuum can't keep up, your database falls over. And there's just like all these problems that have been around for such a long time. And like Postgres is a great product, and like it is a really great system, but the way the Postgres core team approaches things is they approach it in terms of stability and how do we keep what we have today, like how do we keep it working and how do we make sure we don't break it? Because like there's like billions of Postgres instances out there. And so number one priority is just how do we not break the existing stuff versus how do we actually fix the things that are not working. And so PG Rust, because it's a new project, we can take a little bit of a different approach of let's try to actually fix the things that aren't working. And maybe some of the existing stuff, it's not going to be quite as reliable, at least upfront, as Postgres is, but at least we'll be able to fix some of the longstanding architectural issues that Postgres has.
Yeah, it makes sense. How did you do it? It's a lot of, obviously, it's with Claude, right?
Yeah, it took a couple of attempts to actually figure out what is the best way to do this. And what ended up working really well was with Opus, we were able to take each file of Postgres and basically transpile it to Rust. And so if you look at our code and look at the Postgres code side by side, it actually looks very similar, where like the functions are the same. Some of the details may be a little bit different, but overall, it's actually really close to just a straight rewrite of Postgres. And so we did this across all the files. There were some things that had to be changed to actually work in Rust. One of the big ones was how memory management is done, because Rust is very particular about how you allocate memory. But this approach of going through all the files, rewriting them, we had a bunch of Claude agents like going at this in parallel. There were like some conflicts between different files, but we were able to resolve those and then get pgrust to actually work. And then from there, we focus on the Postgres test suite, getting all of that to pass. And we have something that actually looks a lot like Postgres, but is in Rust.
I have a potentially a minor question on the source code. Really interesting that you went file by file and that worked well. One of my favorite things in the source code is the comments, and they describe in quite a lot of detail how things work. And I wonder if you've noticed how it rewrote those. I can imagine the code being somewhat reliable in terms of it being translated, but I can imagine the comments actually being harder in some way to be trustworthy. What have you found on that front?
Yeah. For the comments, like Claude is very verbose when it comes to comments. And like it'll every file have a whole like big comment about like what's in the file. That I've actually had to give it I had to give it feedback to like comment less. And I think there's a linter that's file should not have like more than 5% of the line shouldn't be comments. Um, I haven't paid quite close attention to the actual like content of the comments, but I do know Claude is making a lot of comments in the new code.
It does, yeah.
Sure.
Yeah. So I remember, so now it's version 0.2, right?
Yep.
Yeah, and I remember version 0.1, I think there was a claim that all tests pass, but when I wrote some silly stuff, like not obviously not SQL syntax, it accepted it without any errors. Now it's not so. In 0.2 it works fine, so it looks like Postgres syntax is implemented very well. Was it about some lack of tests in Postgres tests for checking negative stuff? I don't know. What or it just was in complete implementation before? What changed between 0.1 and 0.2?
Yeah. So pgrust 0.1 was largely rewritten by Opus, and Opus I found to be a fine model, but it's a bit difficult to work with. They'll mislead you a bit about like how much work is actually completed. We would ask it to rewrite this file, and it would rewrite half of the file and not all of it. And so we were working with this underlying unreliable model, and like all models are like unreliable to various degrees. But with enough quality controls and layering on top of it, we were able to get all of Postgres ported, and we were able to get the Postgres regression suite to pass. But that's actually a really low bar. The Postgres regression suite on Postgres only has about 2/3 code coverage. And so you can pass the regression suite, but there's still 1/3 of Postgres that isn't even being tested. And on top of that, the regression suites are largely more like functionality tests that every feature in Postgres, there is a regression suite for it. That's like, there's one for cache joins, there's one for lateral joins, and there's 50,000 of these that basically just go through every single Postgres feature and make sure it works to some degree. But they actually just do a couple tests for each feature and then move on. And so the tests are more about just making sure this feature is there and it exists and works well, but doesn't actually really like, do you have a perfect implementation of this feature?
So there is an idea to improve regression test suite, right?
Yeah.
And this should go to upstream maybe, no?
Yeah. So what we've been doing, the difference between 0.1 and 0.2 is 0.2 was written by Fable, which we have a more reliable model now that is more consistent about, okay, you ask it to port a file, it'll actually rewrite the file completely. And so we do end up with something that is just baseline, more similar to Postgres. And then before we released 0.2, we started doing a tiny bit of differential testing and fuzz testing, and I can talk a lot more about that. But for 0.3, we're actually like going to have a lot more of that. What we've thought of doing is we could add like more regression tests, but that again, every single regression test is only testing a small part of the functionality. And what we really want is not just, hey, I can choose 100 tests and they'll all pass. I want to know, is this thing actually identical to Postgres? And some of the things we've been doing, and I was very surprised by this, that this even worked. I would have never thought this. We found this library called Connie, which can take Rust code and C code and do formal verification over the code.
Without any execution.
So it does symbolic execution, So it'll run your code, but it'll run it in a special way that it is more just picking out that, hey, this is an if statement that is checking this condition, as opposed to actually having variables go through it. And then it'll be able to convert that into a format that you can then do formal verification over that has the Rust, it'll have an expression that represents all the Rust code. And that'll have the same for the C code. And then we can do across all inputs, are these two things going to produce the exact same output? And so Postgres has 3,000 different user-facing functions, everything from substring to regular expression matching to there's like you can calculate the gamma function. There's a function for that. And so for about 1,000 of these functions, we were actually able to do like actual formal verification that the Rust code and C code are the same. But then beyond that, what we've started, like formal verification doesn't work in all cases. It's actually narrow. And so what we've been doing for the rest of the code base has been, we'll take the Rust code and the C code and put them side by side, and then have a fuzzer, like code coverage guided fuzzer, generate millions of inputs across the two and make sure that they behave exactly the same. And in the process of doing this, not only did we like find over 100 bugs in like pgrust, but we actually found at this point a little bit over 20 bugs in Postgres itself.
That's interesting. Have you reported them?
Yeah, if you look, I think like end of July, like first week of August on the like PGSQL or like PGSQL bugs mailing list, like you'll see a lot of the form submissions are actually from me.
That's cool. I missed it. It's cool. Congrats,
Yeah.
actually. That's good. Yeah.
None of the bugs, I found 3 serious bugs, but all of them had been found already by other people. I'd been testing on 18.3, 18.4, and in 19 people had found them. There were a lot of not serious bugs that people had not found. One of my favorites is Postgres has a quad tree implementation, and it will use floating points to represent the positions in the quad tree. And there was a bug where, because of floating point rounding and the arithmetic that Postgres was doing, it was possible for a point to not be in any of the 4 quadrants, that the comparison would say, this isn't to the left, this isn't to the right, and this isn't in the center. And we're definitely doing like very aggressive, like,
This is in SPGist, right?
I think it was in, I don't know exactly, I want to say it was in just, yeah, but basically the amount of testing we're doing is so thorough that like we're actually like finding these like extremely
Right.
hard to find bugs, and like we're finding like quite a few bugs in Postgres itself.
This is very important because it means that with AI you basically have some mechanism which is finding bugs all the time, right? And it can be maybe like what could it mean? Probably there is Postgres farm for testing, which is used for all releases. With this work, it maybe like it should be extended to involve more AI and find more bugs at scale, right?
Yeah, there's a couple things I think that are really interesting. One is that like with Mythos, there's this whole thing about like Mythos can like huge security risk. The interesting thing about the models is like the security, the way that they pose a security risk isn't that like the model looks at your code and can find a bug in the code. It's actually that the model can build tools that can then find bugs in your code. Or like I've been using Fable, and a lot of times it'll fall back to Opus 5 because it's, oh, you found a memory bug, like that like seems like a security issue.
I think like just from my experience, I also found a couple of bugs with AI, and one of them, a few were security related. One was officially registered and it was already patched. And that one was just looking at the code. So model was looking. I didn't use Mythos, or even not Fable. It was like, I think, Opus 4.5 back then. And I just was looking at the code. It was very old code, and just looking at it, it found a SQL injection which is there already 18 years. So in some contrib module which is not used directly, so nobody cared, but it was actually serious because it used as example, right? So anyway, it was interesting that just looking at code, it also can find bugs. But you're right, building tools is even more powerful because just looking at the code, you can miss complex relationship between various code pieces, right?
Yeah. So with the models, like what you can do is you can basically point them to be like, hey, I have 100 functions in this code base, write really thorough tests
Right.
for all of these different pieces of code. And so the way I like to think about it with these models is you can if you can get them to do one task well, you now have a repeatable way to do that one
Yeah.
task 100 times. And so if you can get a model to be able to test one function, like there isn't a reason you can't get it to test 100 or 1,000 or 10,000 functions.
Yeah. How much of AI capacity have you already used? Is it like just one $200 account or a few? Or I'm just curious, very curious. Asking for a friend, so to speak.
The first version of pgrust, the 0.1, which was done with Opus, which that spanned 5 different attempts, that cost about 100 grand. And then so
Mm.
far with the new version, like 0.2 and will become 0.3 in total, we've put in probably like another like 300 or 400 grand, where we're burning tokens so fast that like you can burn through a 5-hour quota on a $200 a month subscription in the order of like 15 minutes. And
Yeah.
it's because for a while, like what we'll do is like we'll have 40 different Fable instances like running in parallel, each like working on individual parts of Postgres, and that just burns through credits super fast.
Yeah. Yeah, that's impressive. So, yeah. And it takes also a lot of time, right? Because like it's just they are like you just need to wait sometimes a lot, right? What was the longest run or loop fully autonomous? Like days, weeks, or something?
I usually will, um, I've had stuff like run overnight that worked, but I think I try to keep things on the order of, I try to break things down to like tasks on the order of like ideally like an hour, because any more than that, I find that like the chance of the
Mm-hmm.
model going off and doing its own thing and like getting stuck.
Misaligned, yeah. Yeah.
Yeah. I found that like models, they work really well. They enter two states. Like one is they like are just like working really well and making forward progress. And then other times they'll just start doing their own thing. They'll just start making like a bunch of random edits to like code everywhere and not really go anywhere. And like the more you can keep models on like the productive side and not on the going in circle side is better.
I'm curious on because that's a lot of money to spend on V0.2. Are you being public with how you're funding it, or like if you do you have investors?
Yeah, so far it's actually been entirely funded by me, where I had a previous startup, Fresh Paint, which did like pretty well, and I had the chance to sell some of my equity. And so far it's mostly been funded by me. We're hitting the point where like it's starting to become like a bit unreasonable, and we're starting to look at other ways to like fund money and can we like be more token efficient and things like that.
That makes a ton of sense. So yeah, going back to the technical stuff, I was going the test suite is really interesting to me, and almost as a what can we learn from a Postgres perspective, as well as how could pgrust become trustworthy. So on testing the functions, I can imagine a huge amount of the kind of user surface area is going to be covered nicely, like especially for single user, single query correctness. But I can't help but feel nervous about like concurrency stuff, and even Postgres and some other databases that have had some interesting bugs come up when Jepsen have got involved and that run some like interesting tests along the like isolation level side of things. Does your testing approach cover that yet, or are you going to have needed like a slightly different approach for some of those things? How are you thinking about that?
Yeah. We're basically taking what is the modern and latest approach to testing and trying to incorporate all of that into how we do things. And the first thing we've been doing is we've started with the easy part of, okay, here's all the pure functions, here's the ones that we can verify, here's the ones that we can just fuzz. And then most recently, I've been working on how can we actually get full coverage of the database where there's a lot of very stateful things that will only trigger bugs in very rare circumstances. And if you actually look at the issues people are reporting for pgrust, it's usually the combination of two features of, oh, if I use a non-default correlation with certain string functions, it'll cause a bug. And so what we're trying to do now is actually fuzz until we get to 100% code coverage. And then for the concurrency stuff, once we have a fuzzer that can actually properly explore the entire code base, we purchased this tool called Antithesis, which does Jepsen style fault testing. It's actually a super cool product. They run your software inside of a VM and then are able to inject faults into your running code. And so that can be everything from the network is unreliable and your database can't talk to its replica, Or it can be like, hey, your server crashed and now is your data corrupted on disk or not? And they actually do stuff of they have full control of the threading. It's fully deterministic. And so they can create all these weird out of order sequences for your threads to try to just like throw the craziest stuff at your software. And right now we're working on the fuzzer to actually explore the search space. And then once we have that, we're going to give that to Antithesis to then try to come up with all these crazy ways of running the code together to try to break pgrust. And so I think we've actually been talking with a lot of database people through this, and basically they're all using Antithesis for their testing at this point.
Yeah, speaking of testing, I remember I noticed on Hacker News comments that on the thread that people asked questions about was F-Sync on and did you do writes in those tests and so on, or just only from memory data feeds like buffer pool or something and nothing touches the disk.
Yeah, so we have, if you look at the code base, we actually have a crash simulator in pgrust that mocks out the file system, and then we'll try to just crash the database at different points. And we've done a good amount of testing. The thing is that even Postgres does get these things wrong sometimes, that there was like a F-Sync gate almost like a decade ago now, I think, of like, yeah, F-Sync can actually fail, and Postgres actually didn't handle that case, which, like, to be fair to Postgres, that's a case that never ever happens.
Honestly, I also think, to me, going to Jepson tests and multi-node, basically network testing and so on, is maybe not the biggest priority for this, maybe, like in my opinion. I recently learned that Postgres' own tests are not checking properly disk outages, for example. So this is like, what happens if disk just has some problems? And there are some tools to improve that in Postgres' own code base. So I'm very curious. This is purely vibe-coded thing. You obviously created good harness to map and so on, but still people reported some sec faults. Also, obviously, it's early stage. Will it reach some point when it's very reliable so it can be put to production? So obviously you say yes, but what's your, like, why do you think so? Why do you think yes? Because I'm also very AI positive, so to speak. I think actually in a few months we will be able to revisit with new models and polish it and so on. And it gives me so joy to work with AI together, like human plus AI, we can achieve a lot. But still there are so many doubts around, and people think, for example, it's impossible to achieve a point where it will be reliable. You started with reliability, right? Then you said hackers are too conservative. But there's also, they are too conservative to protect that reliability thing, right? Now with vibe-coded thing fully rewritten, won't it take 10 years to achieve very reliable state? What makes you think it's possible to achieve it much faster than 10 years?
So I think for the issues that people are reporting, I think one thing to clarify is that so far for version 0.2, we had, or actually I think for version 0.2, that was actually before we had done even like most of the fuzz testing I was talking about, where like we actually sorted out those issues. The correctness work has like largely followed version 0.2. And so far we've only covered like 15 or 20% of the code base. And like, there's still a lot more to cover. And so I'm totally not surprised that people found issues in the version we released, just because like we hadn't actually hardened it that much. And to answer your question of how we can actually get this to a place where people can trust this, back to what I said earlier about, it's not like the models themselves are like reviewing all the code and like making sure it's correct. What we're doing is like we're building tools to actually make sure it's correct. And we're doing it at such a degree that like we're able to do millions of inputs for individual functions, to the point that like Postgres, this 30-year-old battle-tested code base, we're finding bugs in it that no one had found before, even though people have been using it all this time.
You find bugs in the old code, but maybe you have bugs which you haven't explored in new code yet. So this is a really tricky question. What's your plan to prove it in production? Just wait for people who will try it in production on replicas, for example, because you obviously this thing can work as a physical standby. Is this a way, or use some mirroring, for example, pgdoc has, or maybe some others have, to mirror traffic and see that it works well? Or what's your plan to prove with production that it works?
Yeah. So for proving it like actually in production, our plan is to do exactly what you said and replicate off of people's existing databases and be a like read-only standby. That gives people a lot of the benefits of like what we're building in terms of this like ultra-fast columnar workload, such that like people who are trying to do analytics in Postgres and are struggling to do it, they can stand up pgrust and then move the analytics over to that. And the really nice thing about analytics is they tend to be like semi-production workloads where either like it's internal usage and okay, your database goes down. Okay, my internal dashboards are broken for a little bit. It's not the end of the world. And then over time, as like we start to get like battle tested in these not tier one database use cases, that's I think will give people more confidence that, hey, this is actually something that like works well.
So what I like in this idea is that if pgrust is powering a physical standby and then it crashed, for example, but primary won't be affected, right? Because, okay, some slot is not used. And if it's working and you run very long running query on it, usually it's a bad idea on regular standbys because of hosted by feedback dilemma. If it's on, it will affect vacuum on the primary. If it's off, it makes your node basically single user. It will start lagging. So both choices are not okay if you want analytics. But it's only true if those queries last like hours. Mm-hmm. If it's already, as your blog post suggests, 300 times faster, then Xmin Horizon is not blocked by hosted by feedback for long. It's blocked for a short time. And this is very interesting. So this looks promising, right? Like we have very fast standby, which behaves exactly like Postgres for like primary thinks it's like Postgres, okay? And we have ability to run some aggregates and so on very fast.
Yeah,
that's interesting.
Actually, the thing I find like really interesting about pgrust is like there's actually a whole bunch of like unexplored design space, like new ways that we could like you can do things. Where you mentioned, for instance, that like when you have a replica, like due to the way like the wall replay works, there's all these like complexities about how do the vacuums work and how does like the replica like fall behind. But I think there are options out there. I haven't explored them thoroughly, but there's options out there. If we change the file format and the way the wall replay works, maybe there's ways to actually get around these problems. I think this is like a lot of what's really exciting about pgrust is like there's a lot of like unexplored design area. And because it's this like experimental new thing, there's actually lots of opportunity to explore the design space.
Right. But that's for sure. So like experimental, like you can go very far. But grounding is when you put it to production. Mm-hmm. Right. And this is the most interesting practical piece here for me. Like, sounds like it's relatively low risk to try it. There's a way, right? That's interesting. So yeah, that's cool. What else? I saw you blog posted, I think today, right, about JIT, just in time. What attracted your attention? It was just switched off by default finally recently. Yeah. Postgres, like, yeah.
Yeah. As part of the columnar stuff, we looked at a bunch of the recent database literature and incorporated a ton of stuff into pgrust. A lot of it actually coming from the research into Umbra, which is this very experimental database being developed by this team in Munich. And they've been like publishing database research for the last decade or more, and a lot of it comes from them. But for JIT compilation, and this is a lot of what I talked about in the post that came out this morning, if you look at all the databases that have JIT compilation in it, they either use LLVM or they'll write C and C++ code and then compile that. And the big downside of these approaches is that there's actually a huge amount of latency overhead to compile this code. That for C and C++, or for LLVM, I think it's 50 milliseconds compile time. And so you're very limited in the cases that you can use it. And you have this risk of, if the planner estimates the query long, you now have this extra 50 milliseconds of latency. But there was this approach to JIT compilation called copy and fix, or something along those lines, that was released someone published a paper on it in 2021 that makes
copy and
patch. Yeah, that's it. That it's much easier to write. That you just have templates of assembly code, and then you just fill in the bits as needed. You can combine these templates together to get the code you want. And so the pgrust JIT compiler actually doesn't use something like LLVM. It actually just directly generates the assembly. And so because of this, the compile times are like 5 microseconds, as opposed to 50 milliseconds for LLVM. And so this gives us a lot more like we can JIT compile a lot more of the query that we actually, for our executor, we JIT compile large parts of the query, not just expressions, which Postgres will only JIT compile expressions and tuple deforming, but we actually do a lot more than that. And so we get measurable speedups in many different cases.
Do you see any reason Postgres couldn't use a similar approach?
So one of the challenges I see with Postgres taking up this approach is I specifically am targeting only the Graviton instruction set, where
Okay.
pgrust is being built in a very different world where today most people are running their databases in the cloud. And for instance, there's no Windows support in pgrust yet. And so I'm able to, because I know, I'm just assuming that people are going to run this primarily on AWS and GCP. I'm able to target one specific CPU design and one specific instruction set and focus just on that and make that work really well. And for Postgres, I think it's still possible. You could have the JIT compiler only work in certain instruction sets, or you can have different backends for different instruction sets, but it's an order of magnitude more work to get that to work well than what I'm doing.
And even if it's not in cloud, they will run it on Mac Minis they have now, right? Anyway, should work anyway there. Yeah.
I've seen multiple people with like rooms of Mac, like they'll have a bunch of Macs in the corner.
Could be a good Postgres cluster. Yeah. So that's interesting. And you don't use GPT like codecs, no? Like distributing workloads within.
So in my experience, actually, like a lot of the early work we were doing with codecs, like Codex 5.4 and Codex 5.5, the thing that made me switch to Claude is they released this feature called dynamic workflows, which this is what was used for the Bun Rust rewrite. And dynamic workflows you can basically, it will write code that orchestrates a bunch of different agents. And so you can be like, hey, I have these 10 files. Can you rewrite all of them? And it'll write some JavaScript. They'll then spin up 10 agents. They'll then rewrite each file and then review it and fix any issues and then merge it. And so that level of orchestration made it way easier to use Claude. And then in my experience, like Fable just works. It's like way more reliable and trustworthy. One of the actually like biggest challenges I had with the rewrite, or like one of the things that's actually really hard, was the Postgres regular expression engine. I don't know what it is about it. I think it's 10,000 lines of code. It's like a decent amount of code, but not too big. And I was doing this as a benchmark, and I threw Sol at it on like medium level thinking, not like the highest thinking, but like on like a decent, like Sol's like a pretty good model. And Sol wasn't able to rewrite it in Rust. I was like very surprised by that. I was like fully expecting that, like, given how smart Sol is, like it should just be able to do that. Whereas Fable was like a whole level above that, where it was able to rewrite in Rust, and then it was able to do like performance optimization on it to make it a tiny bit faster than the Postgres version. And so like I like it probably is possible to use like Sol, but like I've just found the difference in autonomy between the two models is like not worth the difference.
I think we need to talk about licensing. I noticed you picked the AGPL. Yeah, that's always controversial, but at least open source, right? Why pick that one? I think I know why, but why?
Yeah, we were looking at the different options we had for licensing, and there's like 4 different options. You have MIT or like Postgres, you have like AGPL or like GPL, where it's like the copy left. You have what they call like source available, like you have SSPL and like BSL, and then you have like closed source. And we knew we wanted to do something open source, and so that limited us to like the like permissive or the like AGPL.
Copy left.
Yep. And the thing was like we wanted something that like a third party couldn't just take and sell themselves to the detriment of like the work we're doing, where like there's lots of like closed source forks of Postgres. You have AlloyDB, you have Aurora, now like Neon is closed source, and none of that money actually that like those platforms make actually goes back, or like very very tiny amounts of it goes back to the actual Postgres core projects. And that was just something that like I wanted to avoid with pgrust.
But AGPL doesn't protect you from selling. Anyone can still sell if they don't modify code. And even if they modify code, they just need to publish it. That's it.
Yeah. Yeah. So at least the history for AGPL is it is like extremely, basically no one has really done that. Like just the cost of needing to open source your modifications to it has deterred like Amazon and Google from offering any AGPL software on their platforms, at least so far.
Makes sense. Yeah.
So that seemed like the right trade-off.
Good. I know we're
Nice.
almost out of time. It was an interesting discussion. Thank you for coming, Michael. I enjoyed it very well. Good luck with your project. We'll be keeping an eye on it.
Yeah, of course. Thanks so much.
Thank you. Have a great
Take
week.
care.